Welcome back. Today we're going over experimental and theoretical probability. Now, there is a difference between the two, and so to know the two vocab words, experimental probability, that means the ratio of numbers of times an event occurs to the total number of trials. So we're saying if I do something 5 times, that would be the total, and then we would say the number that something occurred. So if I were rolling a dice, or a die, and I were to roll it and see how many times I get the number 1. Well, that would be the number of attempts that happened, would be rolling it 5 times. That would be our total for the trial. But then for the number of times that it occurred, if I only rolled 1, then I'd say 1 out of 6. 1 out of 5 because there were 5 attempts there. But yeah, so there's some different things you can do with that. And the way we look at experimental probability is it's something that we would say, what does happen? So in an experiment, something could go wrong or something could go fabulously right. Whatever it is, it's what does happen. In theoretical probability, the probability of an event happening is based off of the possible outcomes. And basically what that means is we're just saying this is what could happen, and in there it says this one is what should happen. As far as the information goes, like this is what should occur, but when you do your experiment, it might not always happen that way. All right, so next part, the spinner below, we're going to use it to answer the questions. Then spin the spinner 10 times and complete the table. So if I were to go ahead and spin this one 10 times and then complete the table, I actually have a little chart for this one, and I'll show you that one because in order to answer these questions, there will be a couple of things with that. But we're just going to go through the theory of it first. The very first one says, what is the theoretical probability of spinning a spinner with stripes? So in theory, it looks like there's 8 total outcomes, and only one of them is a stripe. So I would say with this one, I have a 1/8 chance of spinning a section that has a stripe. And then what is the theoretical probability of spinning a section with stars? Well, there's 2 stars here, so that would actually be 2/8, which would reduce down to 1/4. So I have a 1/4 chance of getting it to land on a star in theory. And then the last question here, what is the theoretical probability of not spinning a solid or a stripe section? So that means this solid one, solid, there's 4 solids and then a stripe, so that's 5 total. But that's for if I were spinning it, but for not spinning it, well, I have a star, star, and dot that are not solid or striped. So I have 3 out of 8 possible outcomes there. Okay, so using that information, I'm going to go ahead and start this little video here. In this video, I'm going to tally up the experiment. Like this is something I put together and just did, and you'll have to ignore the colors. I couldn't really create a wheel that had the exact same stuff that was on the picture before, so I just wrote the words. And I'm going to go ahead and tally the experiment based off of this information. So if it'll let me, there we go. All right, so it's going to go ahead and spin. And it looks like the first one was a star, so I go ahead and put a tally mark down here at the bottom. And then the second one was a dot, so I'm going to go ahead and put a tally mark for dot. Then another star. And it looks like a white space, so I go ahead and put one for there. And then another one for star. Then another one for white space. And then another one for star. And another one for star. Okay, so if we look at this one, the total number of spins, I had 8 total spins just barely. And from those 8 spins, I had 0 that were stripes. And the experimental probability of that would be 0%. So because in my experiment, I said that there was a 1/8 chance in theory, but when I actually did it, I got 0. So for that one, and then same thing with the white, I had a 2 out of 8 or a 1/4 chance of getting the white space. and that would be a 25% or 0.25 probability. So the next one with dots, I got a 1 out of 8, and the experimental probability of that, if I divide 1 by 8, I get 0.125, and that converts to 12.5%. So I had a 12.5% chance that I got the dots there. And then stars, 5 out of 8. That means I have a 62.5%. So the stars, even though, I mean, there were a couple of ones with stars, but I got it 5 out of the 8 times. So in theory, I should have only gotten it 2 or 3 times. I can't recall what it was on there, but I shouldn't have got it that one. But when we take an experiment and we do an experiment, the theoretical probability doesn't move over to experimental. When you experiment with the probability, it's going to be varying, and there will be some things I'll show on that. All right, so with this one, why are any of those, let's see, are there any results in the theoretical and experimental probability that are the same? Why or why not? Well, first off, the answers, they vary based off of the spin. But students, you should note that the experimental and theoretical probabilities, when they match, they are able to, I mean, you're able to get them closer and closer, but there's something you have to do that will slowly but surely get closer and closer to the theoretical probability. So when you spin the spinner, and you'll look back through the one I did, see which ones match, see if there was any matching with the actual probability that was there. Now, relative frequency is a fancy little phrase, and it's basically a total number of successful attempts divided by the total number of trials. So it can be used to make predictions. And then as the number of trials increase, the relative frequency of an event will approach theoretical probability. In fancy words, that's what it says, but in regular words, the more times you do something for an experiment, the closer it'll become the theoretical probability. So here we have this spinner. I just spun the last spinner 8 times. Well, this spinner, I'm going to go ahead and spin it 50 times, and the results from that right here are shown. Well, I got 12 ones, 8 twos, 13 threes, 10 fours, and 7 fives. So if I were to do the relative frequency, I would have 6 out of 25, and that would be 12 out of 50, but both can be divided by 2, so I get 6 out of 25 for the relative frequency. And then the next one would be 8 out of 50, and then they're both even, so I can divide it, and I would get 4 25ths. And then the next one would be 13 out of 50, and then the next one would be 10 out of 50, but they can both reduce dividing by 5, so I'd have 1/5. Actually, dividing by 10, I don't even know what I'm saying there. So we get 1/5, so the last one there would be 7 out of 50, because it can't reduce, and that would be spinning it 50 times, and that the relative frequency here, that's the number that occurred out of the total number of attempts and then reduced. So if I were to spin this spinner 100 times, these relative frequencies would get closer and closer to the relative frequency of the probability of the theoretical probability. But you'll notice here that all of the results, they're getting really, really close to 20% or 1/5, which this one right here is 1/5 exactly. And then if I were to spin it 100 times, it would get closer and closer, which I'll have another video that'll show this in more detail. But when you use experimental probability and you make more and more attempts, it'll get closer and closer to the theoretical probability. Okay. So with that one, noticing from the spinning 100 times, the pattern that we discovered is that theoretical probability, it's landing for there, it's 20%. And if the theoretical probability is 20%, after 100 spins, most of the experimental probabilities are going to be really, really close to 20%. And then number 4, what is the theoretical probability of spinning each number? Well, spinning a 1, the theoretical probability is 20%. Spinning a 2 is 20%. Spinning a 3 is 20%. Spinning a 4 is 20%. And spinning a 5 is 20%. And the reason it's 20% is because you have a 1 out of 5 chance. There were 5 numbers, and one of them's a 1. There are 5 numbers, one of them's a 2. There are 5 numbers, one of them's a 3, and so forth. And 1 divided by 5 is 20%. how does the relative frequency change between the spinner when the spinner is spun 50 and versus 100 times? And you might need to watch the other video for this one, but basically what happens is the number of trials, it increases. The more the long-term relative frequency approaches the theoretical probability. So in regular words, this one, it takes it and it gets closer and closer to the theoretical probability. And then if we were to spin this one 1,000 times, and I'll show that one on the video, we can predict the relative frequency of each spin. Well, if we were to spin it 1,000 times, it's going to be 20%. It's going to be, or extremely close to 20% for all of those. So in our experiment, if we were to do it this many times, it would be almost identical to what the theoretical probability is. Now, I've said a lot about that, but just know that there is a big difference between theoretical probability and experimental probability. And what that is in theory, something could happen, but when you experiment, it's what does happen. Okay? All right. Hopefully this was helpful for you. If you have any questions, please let me know. And don't forget to watch the other video to kind of see a little bit more on spinning 1,000 times and seeing the different amounts there. And hopefully this was helpful for you. Have a great day.